You don't have to go very far on the internet to see people working with LLMs and having the same problem. They're burning up their tokens, running up huge bills. But what if the answer is not token optimization, but something else entirely? My name's Gibby. I've worked everywhere from a design director to a product manager, Fortune 100 companies to Series A startups. Today, what I'm going to go over is a bit of my system where I've stood up an end-to-end product ops system. What you can see in the background here is actually that system running. It's running a design review. And that's just one piece of this, but it happens to be a very token-heavy piece of this. And so what better to use to illustrate how you can save tokens than one of the heaviest parts of my system. So without further ado, let's jump in. So let's dive right in by jumping to a FigJam. What I'm going to do in this FigJam is actually walk you guys through all of the loops that this agentic system is going to go through to review a design. So let's start at the top. We're going to get a Figma design URL. Usually I'm going to get this from dev mode, and I'm going to pass that to Claude Code. Once we're at Claude Code, we're going to invoke a skill, in this case a design system reviewer, and it's going to look up an MCP server. And in this case, that's going to be Figma Remote MCP. And when that Figma Remote MCP does its work, it's going to get something like this. And what you can see here is this is a large text file. It's a lot of code. It looks like React Tailwind code because that's what it is. And every character inside of that code you can think of as representing a token. That's where a lot of your token usage is going to come from. And let me show you how that works. So we're going to get this from the Figma MCP response. It's going to go right back to Claude Code. And then what Claude Code is going to do is it's going to grab our design system rules from the markdown file. It's going to grab our design tokens from the JSON file. And then all of those are going to go right back to Claude Code. And then Claude Code can generate our design review. Now I mentioned at the top, every one of those steps is going to use tokens, but I didn't really show how. Let's jump into an actual sort of design review. Now let's start with showing a review of a very common UI component, a map card. You see these really all over the place. We're going to pass that to the MCP server to extract the data, as we showed before. This is actually the exact same code that we showed before because it came from this review. But to restate, it's just going to give us a lot of markdown file in the form of JSX. And altogether, that's going to be a little over 10,000 tokens, or really just under 11,000. From there, we're going to load the design system JSON file. Now that JSON file is starting to give us hints of being deterministic. You can see here, it has variants, which are deterministic. We don't have to guess. It has border radius, things like that. We don't have to guess. It's defined in this JSON file. Now that's a simple technique you can use right now to speed up your reviews, and if you're not doing that, you should. But that's not going to be free. We're going to have to take all of that and send it, in this case, a little GPU or our LLM, and we're going to have to process it. So what we're processing is actually 10,800 tokens from the Figma response and another 1,500 tokens from the JSON file. Now I should note that JSON file is actually much bigger than the MCP response, but because it's deterministic, it weighs a lot less on the sort of mind of an LLM. From there, the model's going to do its reasoning, but that reasoning also isn't free. And in this case, I'm going to estimate that it's roughly 20% of everything you send to it. So you can actually use this formula pretty reliably. If you send anything to your LLM for processing, whether you have deterministic rules behind it or not, that initial load and process is going to be the initial load plus 20% every time. And not just that, while it's processing, it has to compare against the original response. So it's actually taking that original context of what it received and duplicating it for the review. So that's no longer just 10,800 plus 20%, etc. It's actually doubling that. So we have to carry forward everything we just spent and then add another 10,800 tokens on top of that. So that represents an almost 100% gain in token usage just from doing that round trip. And from there, for it to generate its response, it's roughly 25,600 tokens for that little map card. Now, 25,000 tokens really isn't a ton, but what if you had to fix something in that review? It's going to be another cycle. So you're looking at 50,000 tokens, 75,000 tokens, etc. You can see how this will balloon incredibly quickly. But there's another problem. Now this is one that it doesn't matter what model we're working with, it's just never going to work. I'll show you exactly why. As I scroll down here, you can see there's just a lot of variance here. And not just a lot of variance of this component, but each component is comprised of other components. That's atomic design, that's how you should build them, but that means that every one of those components is going to be a node item in that code block that we saw earlier. And what is that going to do? That's going to go through the same process. We're going to extract the data, the MCP is going to get it, and I don't know if you can read that little text there, but what's going to happen is we're going to be blocked. The context is just too large. I know Claude says that they have their 1 million token model, but I ran this on that same model and it's just too big. So not only did we not get a review, but we still burned the tokens. Just getting that to that point burned about 9,000 tokens for nothing at all. So how do we make this work at scale? How do we get large design reviews with a lot of stuff happening on the screen and small sort of iterative design reviews at the same time without exploding our budget? That's where being deterministic comes into play. What we're looking at here is a design system file. It's in Markdown. You can see we've got a spacing scale. Below that, we've got a radius scale that's mapped to tailwind. These are all the rules that our design system needs to function. We can check anything against these rules. This is what we use to validate. And it's not just that. We've also got, as you see here, our design library JSON file. Now, the differences between these tools, design system is more system. This really isn't about design systems though. What it is about is that we have a base rule that's more sort of ephemeral, and we have JSON for the rules that are actually just dictionary lookups. And because we already have these, that's one step towards being deterministic. So that's great. I mean, obviously our design rules are going to be static, as will be any rules you have, whether it be how you write stories, how you build components. But our response from the MCP is anything but static. You can see here, this is just from a notification. That markup, that's where you're spending all your money and time with your LLM. But every different notification is going to be different. And when this is in a large design, it's going to be several configurations. It's going to be pretty much net new every time. This is not what you should be paying an LLM for. So let's see how we can break out of that. So let's go back to how this works. We get a Figma design, we pass it to Claude Code, we invoke an MCP server, that gets this big markup response. We take that back to Claude Code, we send that to our design system, markdown file, our design token file, combine all of that, and then from there, Claude Code is going to do a lot of work to figure out the response. How about, instead of sending that all back to Claude Code to figure out just basic lookup values, we just bypass that altogether. We're going to start the same. We're going to get a Figma design URL. We're going to pass that to Claude Code, and that's still going to invoke the MCP server. We're still going to get the markup just like we have here, but instead of passing that to Claude, we're going to send that to a local script that lives inside of our repo. This script is going to convert all of that markup into a structured data object that we can compare against our design system markdown file and our design tokens by just doing simple lookups. This kind of work is what scripts have been doing in software for decades. As a result of that script, that's what we'll pass to Claude Code, which is just going to be a very small JSON response telling us simple pass or fail verdicts, and then we'll get our design review. So we took really all of the meat of what Claude was doing and just passed that to a script, and we did that by using deterministic libraries. Very simple. So let's jump to that design review that didn't work. Let's see if this will get it done. Okay, we're back in terminal. And what we have here are the results of the last review we did. Let me go ahead and get the prompt. I'm going to send it the URL and I'm going to ask it to tell us how many tokens it used for the work that it did. Yeah, I went to get a coffee and it was already done. That's how fast it is. And not only that, before it didn't work at all. So it went through all of our variants. It's given me its response on does it adhere to our values, and we're seeing there's some warnings. So maybe we actually need to update the design system itself. That's going to be another video. But the fact is we got through it and it was less time than it took for me to walk to the other room to get a glass of coffee. And let's look at the token output. Now, With these LLMs, it's not going to be able to tell you specifically how many tokens it used. Altogether, we're looking at 50 to 60,000. This is something we couldn't even get reviewed before. And so that's the power you get when you're smart about how you set up your AI pipelines. That about does it for my video. Of course, I'm recording this on April Fool's, and that's pretty apropos for me, I guess you would say. But jokes aside, again, my name's John Gibby. I do consulting on this kind of work. If you have questions about how you might set up your own script, how this might work for your team, please reach out. I'm available 24/7. Links in the description. Like and subscribe, and I'll see y'all the next time. Bye.